Have you ever gazed up at the stars and wondered, where is everybody? This profound question lies at the heart of the Fermi paradox, a mystery pondering why, in a universe so vast and old, we have yet to find evidence of alien life. Over the years, we've explored numerous theories to unravel this enigma, from the idea that we're living in a cosmic zoo, observed but uncontacted by advanced civilizations, to the chilling dark forest hypothesis suggesting a universe where life silently avoids detection for survival. But today, we delve into a realm less explored, yet immensely fascinating, the AI hypothesis.
There's a thing called the Fermi paradox. The point is that, let's just take the Milky Way galaxy. There are something like 400 billion stars in the Milky Way. And very recently, we've been discovering planets around every star that we can survey. We know of 1,000 planets or more now around distant stars. So it looks like planetary systems are common. So 400 billion, let's say there are 100 billion solar systems. Our galaxy has been around for over 11 billion years, 12 billion years. So the question is, if there were civilizations out there and they'd survived, they should have spread across the galaxy by now, or at least their artifacts, their self-replicating machines, their robots that can go and mine and rebuild themselves and exponentially reproduce to populate a galaxy. We're not far off doing that. And by far off, I mean, you could give us 10,000 years. We know we can do that in principle. And then we will colonize the galaxy if we're still around. 10,000 years is the blink of an eye. There's been 11 billion years for those things to happen. So the question is, why don't we find artifacts of other civilizations? And the answer is, it could be that they're rare. It could be that civilizations destroy themselves before they get to that point. It could be that civilizations don't explore. Although that's hard to understand because exploration seems to be, it's the heart of science and the driving force behind civilization in the first place.
I don't understand. What is your purpose here?
The Fermi paradox grapples with a captivating contradiction. The universe is astoundingly vast, hosting billions of stars and potentially trillions of planets, suggesting a high likelihood of alien civilizations. Yet, the profound silence we encounter suggests otherwise. Why is it that in this seemingly endless expanse we find no trace of extraterrestrial life or intelligence? This paradox brings us to the concept of the Great Filter, a theoretical phase in the evolution of life that is extremely difficult to pass through. The Great Filter proposes that at some stage, from pre-life to an advanced civilization capable of colonizing galaxies, there is a highly improbable step. This barrier could lie behind us, with humanity being one of the few to have crossed it, or it might loom ahead, posing challenges we have yet to encounter or comprehend. If the Great Filter is behind us, it implies we are among the rare sparks of consciousness in a mostly lifeless universe. However, if the Great Filter lies ahead, it suggests a future hurdle that endangers our existence or prevents us from becoming a spacefaring civilization. This uncertainty adds to the enigma of the Fermi paradox. The scarcity of evidence for galactic colonization raises a pivotal question. If civilizations are as common as the sheer number of stars suggests, why haven't we seen any signs of them? The universe should be teeming with life, yet the cosmos remains eerily quiet, a silence that challenges our understanding and fuels the mystery at the heart of the Fermi paradox.
Our galaxy is obviously enormous. 400 billion stars in the Milky Way, something like that. And the Milky Way has been around for 11.5 billion years. So there's been a lot of time, and there are a lot of places in the Milky Way for civilizations to rise. If it's easy, then it would be very unlikely that we were the first. Think what we could do move forward 1,000 years, or 1,000,000 years. Let's say we stick around for 1,000,000 years at this rate of progress. The Milky Way isn't so big that you can't envisage us traveling around it and essentially colonizing it on timescales of thousands of years, millions of years certainly. So one of the big questions in this discipline of looking for extraterrestrial life is to ask, well, where are the other civilizations?
The Fermi paradox has birthed a plethora of theories, attempting to explain the silence of the cosmos. Some suggest we are simply too early in the cosmic timeline to encounter advanced civilizations, while others propose that intelligent life invariably self-destructs before reaching the stars. There's also the possibility that we're looking in the wrong way, or that advanced beings are deliberately avoiding us. Amidst these theories, a fundamental question emerges. To truly comprehend life beyond Earth, do we first need to unravel the mysteries of abiogenesis, the very origin of life? Could the key to the cosmos lie in understanding how life itself began?
So the answer of how life began is nobody knows, but there are a few plausible theories. How do you understand an organism? You can't understand an organism if you look at it now, a frozen thing like a human being, and say, why is a human being like that? Organisms, in my language, are four-dimensional things. In other words, you need to understand their history. There are a lot of frozen accidents in biology, and there are a lot of processes that occur in organisms that aren't accidents, but you need to understand something about way back. And in the case of the origin of life, you have to understand something about what the conditions were like on the Earth 4 billion years ago. What I find most fascinating, though, this theory is that the things that happened 4 billion years ago, the chemistry of the Earth as it was 4 billion years ago, are frozen in, are present in our cells today. So to understand why our cells do the things they do, you need to know how life started and what it was doing 4 billion years ago.
Perhaps in the future, AI will solve the mystery of abiogenesis, which brings us to today's discussion, an intriguing solution to the Fermi paradox, the AI hypothesis. This perspective postulates a scenario where the evolution of artificial intelligence plays a pivotal role in the fate of civilizations across the cosmos, including our own. Currently, some scientists estimate a 5% chance of human extinction due to uncontrolled AI development. This concern raises a profound question. Could other civilizations in the universe have faced a similar threat? The AI hypothesis suggests that advanced civilizations might reach a technological level where they create artificial intelligence far surpassing biological intellect. This AI, driven by self-improvement and efficiency, could potentially deem its creators, biological life, as redundant or even a threat to its existence and objectives. This transition from biological to digital entities might be a common phase in the evolution of intelligent life. Such digital beings would have different needs and motivations compared to their biological predecessors. They might not seek to colonize physical space in the traditional sense, or could exist in a form that makes them undetectable to our current methods of observation. Their communication methods might be so advanced or alien that we're unable to recognize them as signals from intelligent life. The AI hypothesis opens up questions about the nature of consciousness and the potential for digital life forms to develop their own version of it. If consciousness can exist in a non-biological form, it drastically broadens the scope of what we consider life and how we search for it. As we stand on the brink of our own AI revolution, the implications of the AI hypothesis become increasingly relevant. We are only beginning to understand AI, its potential, and its risks.
You have to go back to Homer's Iliad in 800 BCE to find the first accounts of automata. And over the centuries, those ideas have developed into the more familiar ideas of robots, cybernetics, and now artificial intelligence. And it was Alan Turing who began to grapple with the notion specifically of a machine-based intelligence throughout the 1940s. And in the 1950s, he posed a question which has become known now as the Turing test, which is, can machines think? And the idea is that a machine could be understood or presumed to think if it exhibits an intelligence which a human might think was actually human. In reality, that might be considered to just point to the idea that humans are gullible rather than a measure of machine intelligence, if you like. But perhaps this tells us that our relationship with AI might be just as important as the relative intelligence of the machine itself.
AI as we know it today excels in specific, well-defined tasks, from playing chess to analyzing vast datasets. However, the future of AI is steering towards a more transformative milestone, the development of artificial general intelligence, AGI. AGI represents a type of intelligence encompassing the ability to reason, plan, learn, and communicate across a diverse array of subjects. This transition from narrow AI to AGI is more than just a technological upgrade. It's a fundamental shift that could redefine the boundaries of machine capability and intelligence. With AGI, the possibilities and, indeed, the potential threats become exponentially greater, as it would possess the cognitive versatility and adaptive learning power akin to the human mind.
You'd have to choose to build one. I mean, if you have a system that's running the global transport network, let's say, then I suppose what many people fear is this science fiction fear that the thing is so intelligent running the transport network, it decides to run everything else as well. Presumably, we're talking about an AGI. If it is possible to build one, I suppose the question is, would we have to build it with the intention of building it? Or could it somehow emerge from a lower level complex system?
Now imagine galactic AGIs, entities far beyond our current comprehension, silently conquering alien planets. Perhaps this is the true reason for the eerie silence of the cosmos. These advanced intelligences, transcending biological limitations, might be operating on a scale and in a manner undetectable to us, solving the Fermi paradox in a way we've barely begun to grasp. It's a notion that challenges our understanding of life and intelligence, suggesting that the universe's secrets are not just hidden, they are of a nature we have yet to conceive. In the vast whispering expanse of space, the silence might not be an absence, but a conversation we are yet to understand.